Hello class, I created this video to answer a few homework problems. Here we are asked to find the probability of obtaining 11 heads in a row when flipping a coin. So, well, first we have to ask yourself, what's the probability of flipping one head, right? And that comes out 50-50, right? 50% of the time we'll get heads, 50% of the time we'll get tails. But if we want 11 heads in a row, you take that probability and you raise it to the 11th power, right? That's the same as doing 0.5 times 0.5 times 0.5 times 0.5 11 times. And we get this answer. So it's going to be 0.0048 or 49 because we have to round. And I just want to double check, make sure I put enough zeros in there, right? This 4.8 times 10 to the negative 4 means if I move the decimal places 4 times, 1, 2, 3, 4, yeah, right? I'm going to round this to 4.9. So we check our answers. We get the well done. Now it says, okay, when we flip the coin 11 times, the probability of getting 11 heads was this value up here. If we did that same experiment 10,000 times, how many times would we end up with 11 heads in a row? So we have to take this probability and multiply by 10,000, right? So really that's just moving the decimal place, but I'll multiply, I'll just show you the work, times 10,000. Right, so we end up with 4.8, and it says round to the nearest whole number, so we'll call that 5. Check answer. We get the fantastic. Next question, number 18. It says 12% of the population are hopelessly romantic. If we pick two random people, what's the probability that they're both hopelessly romantic? So I think it's good to refer to our formula sheet. So we're looking for the probability that event E and event F happen. So two people, we would multiply the probability of E times the probability of F to get the probability of E and F, right? So in this case, we would multiply 0.12, right, or the 12% times 0.12. And we get 0.14, it says go 4 decimal places. So 0.0144. Check answer. Okay. Now it says, what is the probability that at least one person is hopelessly romantic? So that's the or, right? The both was the and at least one would be the or. So we need to do the probability of E plus probability of F, so that's 0.12 plus 0.12 minus the 0.0144, right? Because this is E and F. That's what we found up here. So let's do this in our calculator. So here's my 0.12, right? That's PV, plus another 0.12, that's my P of F, minus P of E and F, which comes from here, 0.0144. So our answer is 0.2256. Okay, we get the good job. Go to the next question. Okay, now we're asked to determine whether a certain antibody is present. I guess if we do 4 tests, right? So if we do 4 tests, what is the probability that all 4 tests are negative? So I guess the probability for one test would be this 0.999, right? And if I square that, or not square, raise it to the 4th power, I get this answer, right? So that's for 4 tests. If I had 10 tests, I would have raised this to the 10th power. If I wanted to know the probability that 7 tests were negative, I'd raise it to the 7th. But since they're asking the 4th, I raise this to the 4th power, and I enter my answer, my 0.996, and it says go 4 decimal places. So I think that's it, 9960. A check answer. We get the nice work. Now it says at least one is positive. So to determine the probability that at least one comes back as positive, well, if the 4, right, out of the 4 tests, we get the probability of 0.9960, we basically do 1 minus 0.9960, and that should give us the probability that at least one of the 4, right? What is the probability that it comes back for at least one of the 4 people, right? So when I did my math, I got 0.004, and that should do it. Final question. Okay, so it says Ari loses 31% of all chess games. What is the probability that he loses 2 games in a row? So again, we're going to multiply 0.31. I'm going to square it, which is the same as doing 0.31 times 0.31. So we have 0.0961. Okay, I check answer. We get the excellent. What is the probability that he loses 3 in a row? Okay, so now I'll do 0.31 cubed. And I get 0.02979. And we have to round to 4 decimal places, so 0.0298 if we round correctly. We get the fantastic. And then finally, the probability that he loses 3 in a row, but does not lose 4. So remember, 3 in a row was this number here. So now if we have to do, right, so we raise this to the 3rd. If we want to know what was the probability for 4 in a row, we'd raise this to the 4th. But what we need to do is multiply this last one times the probability that he wins the next one, right? Because if he loses 3 in a row, but doesn't lose the 4th, that means he actually won the 4th. So what is the probability that he won the 4th? Well, if he loses 31%, the probability of a win is 69%, right? 1 minus the 31, or 1 minus 0.31 is 0.69. So I multiply this by 0.69 instead of multiplying by 0.31, right? So I'm going to take the probability for 3 losses multiplied by the probability of 1 win. And I get 0.02055. And I think we have to round that. Let me just make sure I typed that in correctly. 0.02055. So if we're going to round to 4 decimal places, I should make the 5 a 6. I check answer, and we get the good job. Thank you for watching.